I've been in IT all my career now, well over 30 years. And in my total IT career, I've seen a couple of major disruptive trends come and go that just totally change the world. Cloud is one, a big one. I'm sure everybody knows about cloud. You've got your Apple cloud, your Google clouds, and so on. AI has replaced cloud today as the most talked about, most publicised in the press, in the standard everyday press, IT topic. So everything today has to be AI powered, has to be AI enabled or AI driven. Whereas just 2 or 3, 4 years ago, everything in IT was kind of cloud driven or cloud enabled or designed for the cloud. But today AI has replaced that. And just some of these headlines here that you see, almost every day you see a new AI example, a new AI deployment. Google's new AI algorithm predicts heart disease by looking at your eyes. The ramifications of data that's collected through video surveillance applications, which you have submitted to data being collected merely by the fact of walking into Vivo City this evening, the amount of video surveillance data captured on you, just imagine if the owner of that data does the wrong thing with that data and passes it on to a healthcare provider that's able to predict that you have a higher chance of heart disease. And through facial recognition, that information is tagged to your FIN number, to your NRIC number, and then when you go to apply for health insurance next time, your premiums are either super high or your declined coverage. That is entirely possible and plausible with the degree of AI technology that exists today. And just merely by the fact of attending or visiting a shopping centre in Singapore, travelling on the MRT, catching a bus, crossing the road, we are all contributing data into AI ecosystems. Every time we use an application on our smartphone, regardless of whether it's an email application, whether it's Grab or Gojek, whether it's to order dinner or to book a trip to go for a journey, whether we're using home assistants like Alexa, Siri, all of these applications, Google Maps, all of these applications are AI applications that we are using today. So if for some reason you thought that AI is something in the future, it's coming, it's here already. It's here already, and we are just all submitting and we're contributing, sometimes willingly, sometimes unwillingly, sometimes knowingly, most of the time unknowingly, contributing and feeding all of the AI-based technology that just this pinprick of an example slide demonstrates. So this evening, I want to cover 3 key topics. The core topic that the whole session is about tonight is obviously about number 3. The elephant in the room with AI is the ethical implications and what we need to be aware of as either technology creators or technology consumers, those ethical applications. But before we can really understand and grapple number 3, we need to have just a bit of a baseline as to what AI is and how it operates. Going back from there, I'm sure everybody wants to understand what's changed. How did we actually get here today that all of a sudden AI is just so topical and so everywhere? Okay, so how did we get here? 2019. What has fundamentally changed really within the last 5 years or the last 3 years that has demonstrably changed the applicability and availability of AI solutions today? The first one is availability of data. I've already kind of commented on that. I've indicated at what has happened already just in your journey here tonight in the data that you have helped create and has fed into multiple organisations' AI ecosystems. So the availability of data, thanks mostly to these devices that all of us spend anywhere between 4 to 24 hours per day using. And every minute you spend in front of one of these things, regardless of which app you're using, you are generating data which gets fed into an AI ecosystem somewhere. The second one is the algorithms. And it's not so much the algorithms, but it's the cheap and the powerful infrastructure, the server infrastructure, the computer infrastructure to process this huge amount of data. So just in the last 5 years, the cost of a server designed for machine learning, and we'll find out what machine learning is in a few minutes' time, the cost of a capable server to participate in a machine learning application has come down something like 80% in the past 5 years. 80% reduction in the cost of the box about this high, this wide, so deep that can execute machine learning algorithms. So that decrease in cost obviously increases the applicability of the types of organisations that can buy that technology. You don't even have to buy the technology to run these algorithms. It's in the cloud. You can go to any of the web-scale cloud providers. You can even go to purpose-built niche cloud providers that specialise in machine learning technology, and you can just rent time. So you don't have to actually invest in the technology. The third point is the algorithms and the software which form the frameworks for machine learning, the majority of that software is actually now open source software. So what's open source software? Open source software is any software that is put into a library, just like the library you have outside here, and anybody can go and borrow and take a copy of that software and use it for free. No license charges, no license fees, no commercial costs. The majority of machine learning software and AI implementation models are open sourced. If you want to look any further into sort of where you go, what is the library for all of this open source software, just go and Google GitHub, G-I-T-H-U-B, GitHub, and that will take you to the massive open source library of software in the cloud. When you look back over IT, particularly over my 30 years of career, the majority of my time in IT has been spent down the bottom here. Applications and solutions in terms of what we call transaction processing, banking applications, applications that just process transactions and record data. They create a record of history. Over more recent years, we've had this thing called social media. Facebook, best example, I guess, of a social media platform where the users of that platform actually engage in the platform. There's some two-way sort of engagement, and these systems of engagement have typically, sitting on top of the systems of record, they're using data that is more recently available in what has created systems of action. So with the combination of the technology foundations of the past, together with the availability of massive volumes as well as variety of data, IT has evolved into this era where we've created systems of action. So the action relates to the computer making a decision, the computer actually executing something to cause some sort of physical action, rather than just recording a transaction or engaging with you by popping up an advertisement on your smartphone in Facebook. Essentially, what has happened and what is happening with AI technology is the traditional world of computing is all about programming. Programming with software written in C, in COBOL, in Pascal, in Java, in Python, any of the many and varied computer programming languages, and that programming is being replaced with training. And you're going to find out very soon what the difference is between programming and training. So now let me move on to my second section. I've covered how we got here. What I'll look at next is a very high-level primer on artificial intelligence. So as you can just understand what AI is, and when you hear different terms like machine learning, like artificial neural networks, like deep learning, you'll have some sort of basic understanding as to exactly what that means. So let's start with some examples. What is AI? First of all, some very simple examples is the interlocutor, the technology that we have a conversation with. Siri, Alexa, Cortana, any of these strangely named bots in our smartphones, in our tablets, in that little device that sits on top of the TV or the cabinet at home, that sort of generates either home automation, it tells you what the weather's going to be or what exchange rates are going to be. Simple sort of conversational technology. There's sort of a classic, very classic expectation and perception of AI here in the form of robots, androids. The Android robot device, very mechanically embodied, but in some way representing a human being or a humanoid, that sort of technology is also a very good example of artificial intelligence. Then we have the more recent sort of technology that has been created to beat humans at something. Classic example here is chess, where IBM created, using IBM's Watson technology that beat the world's best chess player, Garry Kasparov. And that happened multiple years ago. Today, computers can beat humans at chess, at poker, AlphaGo, and just this week, the Rubik's Cube. The Rubik's Cube can now be solved in 0.6 seconds by a robot. And that's a mechanical robot. Previous to that, the best human records were circa 4 seconds, 4 to 5 seconds. So we've got our reasoner, our reasoning technology. These days, the majority of AI examples and AI solutions are over here in the right-hand side. The big data type applications. The applications that are taking all of that video surveillance data, the app usage data from your smartphones, your banking history, your food consumption history, your purchasing history from your credit cards. All of that sort of big data sourced, whether it's digital or analog data, being fed into AI applications. And this is where we have the concept of deep learning come about. Very simple definition here to think about in terms of what AI is. Any agent that is able to solve a complex task or goal. So that agent could be a software application, it could be a humanoid, an android, it could be a Siri device, but any agent that is able to solve some sort of complex task or goal that normally a human would be able to perform. So how do we learn as individuals? The best way and the best analogy to understand AI is to understand how we learn. And I've simplified this tremendously. We learn roughly 50% of the time through rules. We learn that 1 + 1 = 2. We learn that a good rule on the stock exchange, if I want to buy or sell stocks, as an example, for example, if the stock price is greater than a 200-day average, then sell. If it's less than a 250-day average, then buy. If not, hold. Very example of a rule. Fashion rules. Blue and green should never be seen without a colour in between. And so on and so forth. Weather prediction very traditionally has been rule-based. These days, weather prediction is much more modern, and it uses what's coming up next on the right-hand side of the slide. So these rules are implemented in very complicated software, and that software is very difficult and complex and costly to develop, to maintain, and most importantly, to test. So NI, up here in case you're wondering, NI is natural intelligence. It's us, our human brain. So the second way that we learn as humans is through training and learning. And training and learning which has some sort of continuous feedback loop. We learn a bit of data, we have an experience using that data, we reflect on it, we adjust and conceptualise what we learnt, and we optimize for the next time. We make a cup of tea. Instead of picking up the kettle by the handle, we pick it up by the side of the kettle. Ouch, it's hot, it burnt me. I don't do it again next time. I've learned from experience and from some observation of some data inputs that the side of the kettle is hot. It's best to pick it up by the handle. We learn through pictures and imagery that this is a cat. And if we see thousands or millions of images of cats, we can pretty well predict what a cat looks like based on looking at the eyes, the paws, even the ears. Likewise for dogs, and likewise for flowers and birds and everything in between. And we have a skill of judgment and experiential feedback to improve accuracy. Very, very simply, rule-based learning is programming. We get programmed to remember something. This is called training. We get trained. AI, in the form of computer-based AI, very simply replicates this. It replicates this in a computer form. So we have two approaches in AI. We have a top-down approach and a bottom-up approach. Rule-based, program-based learning. The bottom-up approach is our training. We feed data into a training model, we adjust some things, we create feedback loops, trial and error. That's all it is. Machine learning through artificial intelligence applications is trial and error on a humongous scale, a scale that you couldn't even imagine to comprehend. So with AI, with machine learning, we have two key phases that you'll hear about sometimes. Training and the inferencing. The training creates the model. The inferencing is the application of that model in some sort of deployment. A piece of software on your actual smartphone has the inference side. There's a huge amount of detail that can be going into here, but no time this evening to dig into what's inside this grey box. So when you hear about artificial intelligence, you hear about such things like machine learning, artificial neural networks, and deep learning. These are the most common acronyms that really sort of talk about what constitutes this field of artificial intelligence. Now, the best way to understand the more detail of what's called the artificial neural networks is to sort of understand the human brain. Because remember what I said a few minutes ago, AI is totally based around the human and how humans learn on the training side of our brain, the training side. Typically not so much these days the rule-based, the program side of our brain. So in our brain, we have 86, thereabout, billion neurons. Cells in the brain that take inputs, take feeds from our physical touch, from our senses and so on and so forth, and our previous experiences, what we've learnt. All of these neurons are connected together and they have pathways through which they pass information, which is typically electrical signals, which is a trigger. The trigger of a neuron firing, which tells me the kettle is hot, fires an electrical signal which connects to somewhere else in my brain that says put the kettle down. Okay? So you've got this massive network of neurons connected together through pathways. They're called axons, just for information. And this massively complicated network creates the human brain that allows us to learn from experiences, make judgment calls, make decisions based on inputs that we sense in whatever form or fashion. One key point to understand here is this concept called synaptic weights, the weightings. The weightings that sort of tell us the difference between red and yellow or blue and green. These weightings typically come about through our actual feedback loop, our trial and error, our experience. So what we do in a machine learning network, we replace this human neuron in our brain with a mathematical equation. And every different AI model has a different mathematical equation here. So there's not one mathematical equation. There's tens and tens and tens of them. And if you're a statistician, you'll just know some of the different statistical methods that are used for these algorithms. We have these mathematical equations. They have inputs, which is our data, sensed from voice, from text, from imagery, from video surveillance, and so on. Those inputs go into the mathematical algorithm and they create outputs. These outputs are an activation function. Has it been triggered or not? So what we do then is we take one of those mathematical algorithms and we multiply it by millions. And I mean millions. Remember, the human brain has 86 billion of these mathematical algorithms that are all connected together in a network. A machine learning network takes millions and millions of them and connects them together in a similar way. So what you'll notice here, if you look very carefully at the left-hand side of the slide, and as we move to the second column, you'll see some of the circles get bigger. What that is representing is that weighting concept, the concept of the synaptic weights of our neurons telling me the difference between red and yellow, between blue and green. So the weighting factor, which is just a ratio, a multiplier, is used as an input to that mathematical function to help the network learn. And it's the creation of the weighting factors, which is the trial and error aspect, the repetitive trial and error aspect of the machine learning function. So we have a training phase. The training phase, we pump humongous amounts of data into the network. We adjust all of our dials here, which is just like a lever between open and closed. We adjust these dials to create weightings. When we're happy with the output, that the output represents the accuracy of a human making a decision, we then have a trained model. This trained model then gets moved into what's called an inference engine, the inference side of the AI application. This takes lots and lots of computing power, but that computing power is getting cheaper. Inferencing takes hardly anything. Inferencing is what's running on your cell phone continuously when you're using Facebook, when you're using Google Maps, and so on. So then what we have is multiple different kinds of these networks. We have simple networks with 2 or 3 layers. We have networks with 4 or 5 or 6 layers. We have networks with 64 or 128 layers. Machine learning typically refers to networks of 2 or 3 or 4 layers. Deep learning, it's very simply networks that have tens and tens or hundreds of layers. The layers representing the level of mathematical functions between the input and the output. And then what you find, if you get more involved in machine learning, there are different models, different kinds of networks that are better suited to voice, to natural language processing, to image processing, to text scanning or text processing, or temperature sensing. So there's all different networks that have different mathematical equations here for different kinds of data sets. Just as a very simple example, when you go on a trip leaving Singapore or coming into Singapore, some very simple AI technology that you knowingly or unknowingly submit to go through either the automated or less automated immigration clearing. Facial recognition, biometric collection, scanning. If you get interviewed by an officer, voice sentiment analysis. Does Paul sound worried or does Paul sound relaxed? Trust me, that type of voice sentiment analysis is very, very cheap. You can run voice sentiment analysis on a free app on your smartphone. Very, very easy to find in either of your favorite app stores. So this sort of AI technology is just everywhere in society. So because of that, we need to understand the ethics. We need to understand the ethical applications, and most importantly, as consumers, as civilians who are potentially going to have our lives impacted positively or potentially less than positively. We just need to understand how it can affect us, and we need to understand some simple questions. So to kick us off into the last section of this of the presentation, I'm just going to play a short video that highlights the key points, and then I'm going to go into them in a little bit more detail.
So we're at this inflection point. Suddenly, all of this data, these algorithms, and the computational power is available.
Things are becoming real that we've talked about, we've dreamt about for decades.
We must develop responsible and safe practices before the power gets too unmanageable for us to control. Artificial intelligence uses a massive amount of data to recognize certain kinds of patterns that are correlated with a successful result.
Hidden in these vast pools of data that we're now using are remarkable opportunities to run off the rails.
Data can be bad because it has baked into it certain human biases that are naturally a part of society.
Our biases will get not only embedded in this one program, but get scaled out rapidly.
What I see is a generation that takes all kinds of life instructions from its device, from an algorithm that you know nothing about.
Who's behind that screen? Who's on the other end of the wire?
If you want the machine to behave in an ethical manner, you have to know why it does what it does.
Whose responsibility is it? Is it corporations, government? Is it society? And it's really all of us.
The New Manhattan Project is not AI development. The New Manhattan Project is AI safety.
It will be human choices that will determine where we go with this technology. It means that the choices aren't made for us about how to manage the new power that these technologies give us.
AI is going to disrupt our lives. That's a given. We've already passed the point of no return. Just as an example, fully autonomous trucks expected within, 10 years from now. Retail establishments that have no humans are expected within 10 to 15 years from now. AI robots in the operating system theatres cutting us open and working on our faults to fix those faults, within 20 to 30 years from now. The next one, writing a bestseller by 2049. The next Shakespeare probably won't be Shakespeare. It'll be IBM Watson or HPE blah blah, as an AI model. And as an example why this is so possible, everybody knows of Bloomberg, right? Bloomberg, the news creator. 30% of Bloomberg's news content today is AI curated and not reviewed by a human. Not reviewed by a human. All of the company announcements, company annual reports, quarterly stock market filings that Bloomberg reports on, they get fed into an AI engine. Out comes the press releases and the headline articles from Bloomberg, and it goes straight onto the newswire. No humans even look at it. And Bloomberg created that system so they can beat routers to the market with news releases on company announcements, annual reports, quarterly filings, and so on. That's happening today. That's reality. Full automation of labour by 2140. Who knows? I'm not going to be around then, so none of us are going to be around then. But the key thing is the researchers, there's no universal agreement here. There's only, like researchers say, there's a 50% chance of AI outperforming humans' tasks within the next 45 years and automating all of our jobs within 120. For some reason, in this survey, in this research that was done here, Asian respondents are a lot more positive in expecting these dates to be much sooner than North American respondents. But the key point when you start to look at the projections about when AI is going to dominate, there's no universal agreement. So when we're looking at the ethical aspects, there's three key elements to ask questions about. And you can look at this as short-term, medium-term, and long-term. In the sake of time and our Thursday night this week, I'm only going to focus on this first one, which is the short term. What do we need to understand to build trusted and ethical models within the next 5 to 10 years? You can go and start to do your own research on these two in some of the links and the research material I've provided at the end of this session. So there's 6 key areas that we need to understand and be able to ask questions about as to what constitutes trusted and ethical AI. The first is robust. AI does need to be more robust than today's technology because of the scale of the impact of decisions. It needs to be regulated. We need to have a legal framework that really understands the repercussions and the technology that goes into AI systems. It needs to be carefully used. When AI technology goes into autonomous weapons, it just has a multiplication and a scaling factor that no traditional robots or even airplanes can even think or dream of achieving in effectiveness. And it needs to be fair. It needs to be fair to humans so humans don't get thrown under a bus or a truck in job losses and reskilling. One of the most important topics, which was one of the big topics in that video, is the concept of bias. Everybody is human beings. We all have biases, natural biases, learned biases, cultural biases, geographical biases. But biases in an AI model or an AI implementation just have a huge ramification potential that you'll see later. And they need to be explainable. AI cannot be a black box. It has to be explainable. So we'll just have a look at each of these one by one now with some examples to help you understand. Robust and bug-free. This rocket blew up 37 seconds after it was launched because of a bug in a single line of code. Ariane 5. This stock market crash during the 90s happened because the algorithm creator forgot to factor in a particular anomaly with the stock price's opening price of the day. Security, cyber hacks, cyber threats are all around us. If an AI solution is not secure, and if hackers get into an AI type of solution and impact in the data or the inferencing, then the ramifications are even more multiplied than today's sort of security hacks. And we need to have control. We need to have control over an algorithm and a solution to be able to correct it. A very recent example here is the Boeing 737 MAX 8 with the MCAS implementation in this. That MCAS problem is an example of an AI solution that was not implemented properly that has killed something like 500 civilians with the 2 MAX 8s that have crashed before the MAX 8s were grounded. So that's real. Regulated. The law has a long way to go to catch up with AI technology. When something goes wrong, either in an AI system's action, like for example a self-driving motor vehicle crashing with a woman, who gets the blame? The developer of the software? The data set that was used to feed into the machine learning model? Or the person in the back seat of the car that could potentially have overridden the autonomous driving? Right? Who gets to blame? Who do you sue? When we get our AI robots in the workplace, is it harassment to ask them to make us for a cup of coffee? Right? What rights would robots have in the workplace? So there's a whole element here of regulation and laws. So America is pretty advanced here. They started quite a few years ago in recognising that AI needs to sort of go through some due diligence of regulation. And they created a Senate committee, which I have to read out the definition of the acronym here, FUTURE. FUTURE means, where is it? Fundamentally understanding the usability and realistic evolution, that's future, of artificial intelligence. So the US created a bill, it created a Senate committee quite a few years ago, and since that Senate committee was launched, they've come up with dozens and dozens of bills, most of which have passed Congress, around governance frameworks for AI. The European Union has a very good governance model for the trustworthiness of AI solutions, and as well as in Singapore. Singapore recently launched a governance model for AI frameworks as well, which I'll talk about a little bit later. Carefully used. They need to be used for the right reason. So this device here is a autonomous underwater vehicle in Australia, and it's used to help give the Great Barrier Reef a new lease of life. Big problem with the Great Barrier Reef at the moment is crown-of-thorn starfish are killing the coral, bleaching the coral of all its colour. This robot, which is a 100% AI implementation, seeks out a crown-of-thorn starfish, and using this device here, it seeks out the starfish and it goes wham! And it injects the starfish with a very, very strong saline salty solution that kills the starfish. And it's doing this during daylight hours every day of the week, 100% autonomously. Now, do you want to be a scuba diver with a wetsuit that has a pattern on it that looks like a crown-of-thorn starfish? You hope that the robot can tell the difference between a scuba diver with a fashionable wetsuit and a real crown-of-thorn starfish, right? Likewise, when something goes wrong with the technology, again, who gets the blame? You know, this light-hearted cartoon here with today's sort of vacuum robots. Who gets the blame if the vacuum robot actually messes up the house versus cleans it up? We need to grapple with these issues and start to talk about them. There's been dozens and dozens of examples where weapons have gone wrong, where almost we've had a nuclear war because somebody thought they were going to be attacked with a nuclear weapon from the other side, from the other party. The Future of Life organisation, Future of Life initiative, created a paper which is a voluntary code of conduct for AI researchers to voluntarily commit that they will never create AI technology that can be created and purpose-built to do harm or to kill human beings. Now, currently, this voluntary code of conduct has about 4,500 signatories to it. People like Elon Musk, Bill Gates, Paul Allen, a lot of famous people in the tech sector, the late Stephen Hawking, all signatories to this voluntary code of conduct, that their technology will not be used for evil. Fairness. Buildings used to be constructed by humans. In the future, they will be constructed by bots, right? Things that can work around the clock and they don't have to be fed. Just the occasional oiling and greasing with some WD-40 and they'll be happy. Do they need time off? Do they need rest breaks? So the universal opinion here on jobs is that AI will affect the job market. But net, it'll have a positive effect on the job market through reskilling and new opportunities. So yes, there will be job losses, and this data from Gartner, I think, is a couple of years delayed in impact. But nevertheless, the general trend here is that within the job market, AI will create jobs, but they're going to be very different jobs. Those different jobs will be in different industries from the jobs that have been taken away. And the jobs that where we'll have net losses or jobs taken away are typically those task-oriented jobs that are very easy to automate and very easy to repeat. We're very, very safe if we work in an activity that involves judgment, empathy, leading, or learning, because those sorts of job roles will always be human-oriented. They're not going to be replaceable by AI bots. AI bots just cannot have a concept of judgment like the human brain can. Definitely not within my lifetime. If we're in a career that is very task-repetitive, process-driven, transaction-oriented, predictable, then you need to reskill. You need to learn something else. Good example here is the legal profession, legal document creation. The majority of legal documents today are created by AI technology, not by solicitors or barristers. Then in the middle, there's a whole range of sort of zones where machines and humans will have to work together. They'll work side by side. And that in itself creates a whole range of problems and dilemmas to be understood and resolved. Unbiased. Perhaps the most talked about topic here and the biggest impact is the impact of bias in AI implementations. This picture here, a university student, Joy Bulawini, a black female, an AI implementation at her university could not detect her, said she didn't exist until she put a white face mask on. That's using technology from IBM's Watson, Microsoft's cognitive services, and a lot of open source software. And this particular implementation had a 1% error rate for white men, but a 35% error rate for darker skinned women. In America, there's a, you could say, perhaps very successful AI implementation within the penal system, an application called Compass, a correctional offender management profiling for alternative sanctions. That's Compass. So the US introduced this Compass application quite a few years ago to help prisons and parole officers decide whether a criminal has a chance of reoffending. And it gives them a risk profile, low, medium or high. The problem is this application, Compass, was designed for one purpose. Should I get parole or not? And it's now been used for sentencing decisions. It's been used for sentencing decisions. A research organisation called ProPublica did a lot of research, and this is very, very high profile, into the Compass algorithms and found that when the Compass algorithms got it right, it was generally fair across white and blacks. But when it got it wrong, it was totally wrong in the opposite direction in terms of whether blacks were more likely to reoffend or whites were more likely to reoffend. Some good examples here, 3 examples here of three criminals. They were sent to jail and the risk assessments on them were totally wrong. So these 3 examples here, the black person never ever reoffended. They got a much higher risk assessment. They were denied parole or denied shorter sentences, whereas the white person went on to reoffend but was a lower score rating, a lower risk score rating from the outset. One person who was, they felt they were hard done by this Compass application. They took the state of Wisconsin to court over an appeal. The bottom line was that the state of Wisconsin, the Supreme Court, came down in the favour of the state by saying that the defendant could have argued with the accuracy of the data that was fed into the algorithm. How is somebody going to do that? How can you potentially look at the accuracy of millions of records of prison data and decide whether it's accurate or not? So a good example here is we have to work out, how do we argue with an algorithm? Can you take an algorithm to court? Good question. You should ask me that later, Dazzling. The last one, explainability. This is very, very important to sort of get some sort of transparency into AI. We sort of solved this in aircraft travel and maritime travel with data recorders. In the early ages of aviation, when a lot of planes were dropping out of the sky and nobody could work out why, a very successful and famous Australian guy invented the black box recorder, the cockpit voice recorder and the flight data recorder. And these now are implemented just universally, virtually on any commercial aircraft. And as long as we can find the aircraft, we're able to work out generally what went wrong. So explainability and transparency. So a couple of good organisations here are working on this. There's a lot of good research papers on the case for an ethical black box. And there's actually an annual industry event in the AI industry that focuses on researchers to come together to look at the fairness, the accountability, transparency in machine learning. So there's actually an annual event for the AI industry just to focus on this. Within Singapore, we do have a governance model that was released in June, which talks about the recommendations that companies should consider when implementing AI frameworks within their organisations. And there's actually a very good use case example of a local healthcare company in Singapore that has created an AI application that's used in many of the hospitals here that gives you a prediction of your hospital costs for particular surgical procedures. So fast forwarding here to another way of looking at how AI can impact us ethically. And there's 4 domains here that we need to understand. So first of all, if we just think about what AI is, looking at the data sets and the models, we have the concepts of bias and fairness, transparency, explainability. If we look at what AI does, we have safety factors. We have human and AI interaction, machines and robots working together. We have security, and we have all the privacy and data sovereignty type issues. What AI impacts, we have concepts like job loss, labour fairness, reskilling, civil rights and democracy, impact of AI on human rights, and also human-to-human interaction. The very big one at the bottom, what AI can be, nobody has really even started to grapple with. This gets into all the concepts of the singularity principle, the day when robots potentially conquer humans and we become subservient to robots compared to the other way around, robots being subservient to us. So just a slightly humorous but very, very real situation that might happen in the future. My discussion with Siri. Paul, your wife called about dinner tonight. Hang on, wait, which dinner? For your 10th anniversary, Paul, at 8 p.m. Wait, I've got a meeting with Donald at 7:30. How did this happen? I did warn you, Paul, but you overrode my recommendations. What am I going to do? This is a disaster. We've been planning this for months now. Don't worry, I've arranged for his plane to be delayed. Some kind of computer malfunction occurred. He sends his apologies and will meet you for lunch tomorrow. Have a nice evening. So that's entirely possible with a combination of technologies and integration. What I really want you to remember and just sort of take away as I wrap up here, in reality, AI ethics have to mirror our natural world ethics, our human ethics, our natural intelligence ethics. The big questions, though, are, should we expect reasonably for AI ethics to be any better or more advanced than what we have achieved in the human world, in the civilian world? Just ponder simple things like that. And if so, why? Why would we expect AI ethics that are implemented by humans to be any better or superior than humans? So thank you very much for attendance again, and let's invite Dazzling back.
Let's give it up for Paul once again
chat.
for the very insightful presentation. I really enjoyed that. And I love your rubric cube shirt, Paul. Was it a deliberate choice?
It's my geek shirt.
Oh, your gig shirt. It's your good gig shirt, right?
My good geek shirt, correct.
So a warm welcome to the online audience, and thank you for still being with us. Firstly, we'd like to take questions from the floor. If you have any burning questions about your immediate short-term future that might be affected by what you've just learned. Maybe just a quick show of hands. How many of you are, PMETs who have come to hopefully glean some insight to help you, boost your work profile or, work career pivot? How many of you are working as professionals? You're just too shy to put up your hands. Any entrepreneurs or technopreneurs?
Just a bunch of people that want to learn.
Which is great, right?
I think it's
the
because
attitude of learning.
It's only through learning and awareness that, because most big changes in society start from the ground up, right? Civilian-oriented change and ground root type, grassroots campaigns. So the more that we know and understand as civilians, the better questions we're able to ask the creators of technology.
So we're sort of got to put ourselves in their shoes tonight and try and pull that out, and
Yes.
answer some of those questions. But I've got a bunch of questions
Okay.
to address.
You go first
so
then.
I'll fire away. So according to a report, 73% of consumers trust in companies. Says that trust in companies is really important, and 88% says that companies are responsible for ensuring that they use tech and data ethically. So how can companies do that?
So that's very, very true, because there is a lot of research that where people's buying decisions and buying patterns do take ethical brand awareness into consideration. So companies have to realise the effect of ethics and brand power and brand strength, and design into their product creation, their product design, everything to do with their IT systems and AI solutions they're creating, to be aware of this, so as they kind of run the headline test on every decision they make. If they balls it up, if they make a mistake, how's it going to look on the front page of the newspaper?
So we hope that companies would do that, but on the ground, what can consumers do?
So what consumers need to do is have this sort of awareness that I've covered tonight. Some very simple aspects around questions around transparency and accountability in AI applications. Have some questions ready to ask an organisation if you use some of their technology and it is you feel something in your stomach that it's a bit strange. Why has it told you to, or recommended to you, to take a holiday to Miami during the North American winter when you know that you love the Singapore climate, which is hot and tropical? So when you have some sort of gut feel reaction that you think something is wrong, that should trigger an instant go through that list that I talked about tonight, ask some questions, and doubt and have some skepticism about what you've been told or what you're hearing, and just, ask questions.
We'll get to the travelling bit later, and as some of Paul's friends would know, he's quite a globetrotter. So if you talk about companies and a value chain and value creation, there are essentially four groups, right? The policymakers, the people, the engineers themselves, the ones who gather data, and as well as the business side of things. So sometimes we tend to look at ethics as a form of outcome rather than a process. So if we were to work collaboratively together as a body to ensure that the process is done right, what can these four groups really bear in mind, and how realistic is that? Because, you've gone through all the cycles, you've gone into the business side of things before you were an engineer, so would it be realistic to tell, a young engineer, hey, stand up to your boss and tell him that this is not ethical?
Yeah, so everybody in that sort of process flow has to accept and understand they have a role to play, because it's the decisions that are made at every step of the AI journey or the AI pipeline that have an impact on the outcome. Ethics is not an outcome. It's a never-ending sort of process journey of decisions that are made from the very beginning, from the data scientists that work out what data do we need to collect to train this computer model that's going to recommend to people what movie they should go see this weekend. And, just at the very beginning, the data scientists have a role. And then the people that test those models have a role. Every step of the way, there's an ethics question and an ethics checkpoint. Mm-hmm. So everybody plays into this, not just the people at the end point.
It's kind of like the Holocaust, to give a more analog example, right? Because all the bureaucrats who were involved, none of them felt they were personally responsible for the Holocaust, but they all played a part. Yeah. So I think we can draw a parallel between.
And I think everybody has a concept of gut feel. Everybody knows that if they've been asked to do something wrong, or if something's not quite right, they sense something in their stomach. And when you sense that uneasiness in your stomach, then they have a moral role to step up and challenge and to question.
Yeah, but if the weakest link still stands, then I suppose the ball goes back to the court of the consumer, like you said earlier. So speaking of which, I have two scenarios to throw out, and these are real, instances that things got screwed up. So in the States, there was a lady who was suffering from cerebral palsy, and that, she needs a lot of medical care. And, one algorithm decided that she didn't need as many hours to clean, to eat, to have that kind of medical assistance. So essentially, she had her medical benefits reduced threadbare because of the algorithm. And in the second instance, what happened was that you had there was a really outstanding 5th grade teacher who had consistent, excellent, good reviews from parents. And one day she received a letter telling her that she'd been fired amongst 200 other staff on board. And that was also the work of an opaque algorithm. So in this case, who can we blame? Because it's clearly the algorithm. I mean, I'm playing the devil's advocate, right? Can we take the algorithm to court?
Very well, as we saw in the state of Wisconsin versus Loomis, I think it was. No, because Loomis should have checked the data accuracy of the data fed into the AI model that told the state he was a high-risk prisoner at high chances of reoffending. How do you argue with an algorithm? That's a very big contentious topic that nobody has really solved yet. On that ProPublica versus sort of Compass example, there's been a lot of research articles coming up with suggestions as to how lawyers could potentially take appeals to the court where they feel as if, like in your example just then with the two ladies, they were hard done by. How do you challenge that? How do you take the people that made that decision to court where the decision was influenced by an algorithm? But there's no precedent cases yet to look at or cite.
Oh, well. So I think there are two things here. Firstly, people tend to believe that, they tend to hand things over to the algorithms. Clearly, it's a human decision, right? And the second thing is people tend to believe that algorithms are error-free. So it's kind of like in Hitler we trust, but in algorithms we trust. But, from the engineering perspective, how common are such occurrences?
More common than we would probably be aware of. And definitely, it's just happening continuously in our daily lives. For example, when you arrive into any airport these days, there's always a body scanner in an infrared scanner looking at your face and your body to see if you've got an elevated body temperature. That's a very, very simple example of that sort of decision making using some sort of AI system. When that sort of technology is combined with facial recognition, it can be used for all sorts of good purposes and potentially bad purposes as well. And video surveillance and image or facial recognition through video surveillance is probably the most prolific example of AI in modern society. Most of the time it's been used for very, very good and positive type cases. There's a lot of documented cases in China, for example, where the China state has captured people on their wanted list because the person went to the theatre. And they never ever imagined that by going to the Beijing Opera, they would get caught out through facial recognition. But there's dozens and dozens of cases where that's happened. Yeah. So we really just have to, have that awareness that AI is everywhere.
Yeah, that would make for a very good movie, though. So I think we was speaking earlier, and you also mentioned how algorithms get repurposed, and that's one of the areas or aspects where errors can very likely occur because of a process, they've subverted the use of the algorithm for something else.
Yes, and the Boeing 737 MAX 8 example with the MCAS system is a fantastic example of that. I won't go into the history and the details, but the MCAS system was originally designed for one very narrowly scoped purpose to help Boeing compete more effectively with Airbus because they put bigger engines on that model airplane. A lot of details behind it, it's all out there, go and research it. But then during production of the 737 MAX 8, they discovered it had another aerodynamic problem, and somebody said, oh, MCAS can help fix that. Why don't we just extend the scope of MCAS from being this very narrow problem to a broader problem?
Someone had a bright idea.
They didn't go back and look at the scope of what it was designed for, and the repercussions then became apparent where the old problem of garbage in, garbage out occurred, and the rest is really history as to what happened.
So, which is why it's so important that we live by a creed, and in your case, is doing the right thing the right way, right? Because
because
there
were multiple engineers at Boeing that are now coming out onto public record, documenting and talking about what happened with that MCAS application, that MCAS technology.
Right. So that's definitely a process gone wrong. So, so the second thing is that sometimes these algorithms are not necessarily deployed in a way that is, fair in that sense. So what we're seeing now is that the way this has impacted people is through the haves and the have-nots. So how this is played out is that the poor people, in a sense, right, they don't have access to human contact, right? They just have to go by what the algorithms decide, as opposed to the privileged who have that human factor and consultative approach. So is that something we can, mitigate, possibly?
The haves and the have-nots. The haves and the have-nots.
We have a behavioral economist in our midst. If he wants to chip in.
Well, I guess.
It goes back to the question of, it's AI and a mobilizer. Is it an enabler, or is it just going to further amplify and widen the gap? I mean, what is your view?
That's very, very complex. Very, very complex topic. But what I kind of go back to is this slide. I personally don't believe we should expect AI ethics to be any better than human ethics. And as long as we embark down the road about AI technology and don't expect it's going to create something superior that we as humans have never ever achieved with human rights and so on and so forth, then I think we'll be okay. AI technology is created by humans, so why is it going to be any better than what we've achieved for ourselves in civilian rights and human rights? So there's going to be haves and have-nots. There's going to be hard done by people. There's going to be people that are going to do well out of it. Yeah. And there's going to be a whole range in between.
Yeah, that problem is just not going to go away. But if AI doesn't merely mirror the world, it impacts the world, and it's part of the feedback loop. So I've got an example, right? If you have an algorithm that, decides that, hey, we've got a problematic neighborhood here, and we're going to send the police there, then naturally what happens is that more arrests are going to be made. And then this goes back to the AI feedback, and, we need to send more police. And then it becomes a vicious circle of things.
Yeah, and that's the... That example is one of the core issues at heart with that COMPAS algorithm that I talked about. The COMPAS algorithm has data that's sourced from felons all across the United States over multiple years. So the data set is broad, and you could argue averaged across society. But the decisions that it makes are based on one person. Now, the difference between American black sort of convictions and re-offences in Brooklyn, New York, is very, very different to black Americans in Portland, Oregon. But yet, the poor person in Portland, Oregon, that the COMPAS application makes a risk assessment on, he or she gets levelled with the impact and the bias from the black Americans in New York because of that, the issues with the data set and the averaging and so on and so forth. And that algorithm doesn't take that into account.
So let's talk about the social media, because that's a space that we're all in, right? I've lately
Every
kind
day,
of like...
unfortunately.
I've tried to drop off the radar on Facebook for a while, and
But you liked my articles yesterday.
I was just trying to be supportive. Since you're my guest, it's good manners. But we talk about the tyranny of metrics. We talk about optimizing metrics, which is what YouTube does. So do you think that takes out the element of surprise, of serendipity? There was a time for some of us where none of this existed, but now my life does not, not a day goes by where I don't wake up and I'm excited to check my YouTube feed to see what they think, I should be watching. So serendipity for me, and I don't know what it looks like for you, has become like a game of, okay, what are they going to recommend me today? So in that sense, if we talk about, having a moral compass to guide us, which is what ethics is really about, then how do we reconcile with the fact that the parameters have changed, they have shrunk, right? So it might look like, through these YouTube recommendations, that I have more choices, when the truth is, they have redefined our reality. So what would be your advice in that sense, to have that integrity of choice and still exist in this world with the kind of trappings that we have?
Yeah, that's very true, because it's a fact on YouTube that the most consumed, most watched content on YouTube is the automatically played content. It's not actually the content that people will go to YouTube to specifically watch and look at. It's the autoplay stuff that follows on. So my simple thoughts and simple sort of advice there is ask some simple questions to ourselves around the motivational reasons we're being shown something. What's the motivating factor? We've had an ad pop up on Facebook. What's the motivation behind a guy knocking on our door trying to sell us something? Because in reality, that's all that's happening on social media. It's the electronic version of a door-to-door salesman. It's just a damn sight more effective and a damn sight more scalable than a door-to-door salesman.
Right, and it's
so what's the motivation?
Yeah. It's like an online version of Hotel California. You can always check out, but you can never leave. And the haunting intro comes on. I mean, some of you would know what I'm talking about.
Can you sing it? Can you sing it for?
The bass? That will be for another talk show, the Dazzling Tongue talk show. So, just two more questions I want to ask you. So, you've been through like the hippie cycle, you've been through the 80s, the 90s. I mean, you're still very young at heart.
Yeah, this side.
Yeah. So, but what? And it's ironic now that the young people today, specifically the millennials, they're living in that FOMO, that fear of missing out. But I mean, there was a time where you lived without these things. So what do you think they are missing out in that sense?
I think the big thing, and I'm not any sort of social scientist. I'm an IT geek, right?
I'm the social scientist.
You're the social scientist. Well, the big thing I see people missing out is sort of learning by trial and error. That we have to be able to be told everything that we act upon. We have to be able to go to TripAdvisor to be told what restaurant we go to on the city we're visiting. No longer do we just learn by experiences ourselves and making our own decisions. We want to be told by others. And whether that's from a fear of getting it wrong, which has a lot of different sort of cultural aspects to it, the fear of loss of face, of getting it wrong, making ourselves look stupid or embarrassing. Mm-hmm. So I grew up in an era of just, you learnt, you screwed up, you got up again and you went on, you moved on. You fell off the horse, you got back up and you got back on it straight away again. So you just learnt by making mistakes, trial and error, which is how AI models learn. AI models learn through trial and error on a scale that would blow our mind, with millions and millions of pictures of cats and dogs and so on. That's how AI learns.
So to make it closer to home so that we can go back and still be able to sleep, right? AI versus NI. So you talked about NI being, natural intelligence. We've seen the statistics. We know they're coming for our jobs. But is there anything we're overlooking here in the case of our natural intelligence? Because I'm optimistic that our synapses are a little bit more superior than what they'll take to learn.
Yeah, so I guess just one point there, the one factor that the computers have over us, as we age, our neurons are decreasing, so our brains actually regress.
I wasn't expecting that.
Our neurons,
I'm sorry.
We start off with 86 billion, but on average when we go to our grave, we only have like 60 or 70 billion. So we sort of lose 30 billion or so of those neurons as we age. If you don't use it, you lose it. Now, where was I going with that question?
Was that supposed to? I was hoping to find something that would give us hope, but
I think that the absolute hope is that once you just understand the capability of the human brain and how quickly we can learn, I become very confident, and I'm very confident that computers and AI bots will never ever get to the potential of our human brain for judgment and experiential learning quickly type of situations and circumstances anytime in the next 100 or so years.
yeah. So on that topic, this is going to be my last sort of question.
Sorry, actually I've got a question.
Oh yes, please.
So, Hewlett Packard Enterprise obviously is a leader in the supercomputing space today, and obviously AI generating and data sets and all that is a big part of everything you do today. So the question is, what you're doing today with some of your customers in terms of creating AI for the greater good, around Asia, perhaps. Is that something you can talk about?
So very simply, I don't want to grandstand for HPE, but very, very simply, there's three aspects to our AI strategy. One is we create AI technology for researchers to purchase and use to build AI applications. So that's prong number one. Prong number two is we implement AI technology in how we support our customers. So all of our technology that our customers buy from us is all AI enabled. So we're able to solve problems much quicker. We're able to deliver a much better sort of experience to customers through AI technology embedded in our technology. The last one is using AI in our own business, just to improve our own business. Supply chain, manufacturing, quality control, they're all areas where AI can massively help to reduce costs, improve quality, and then create a better product at the outcome.
Cool.
Yep.
And just another question about, obviously, industry trends. Okay. So, obviously, search engines and targeted search for advertising is one of the biggest users of AI today in the market, and obviously data analytics and data sets. So what are your thoughts, in terms of creating the right rules of engagement for search targeting from both a consumer and also a business perspective?
So I think so first of all, I think the biggest absence, what's really missing, particularly from search results at the moment, is some sort of level of explainability. Why is Google showing me this result at number 3 in the list? Okay, it's good. Number 1 and number 2 are disclosed as being sponsored, so there's some commercial motivation there. I understand that, I get that, so I bypass those ones. But number 3, I would really like to be able to click on something that says explain. Please explain, the very famous Australian once said. I would like to be able to click on something that helps tell me why has this result been shown to me? Why does it think it's number 3 in the important list? So I think that's the biggest thing missing, which is basically comes down to transparency and explainability. That's not there today.
Great questions, thanks. So to end off, I just want to bring this a little bit closer to home, right? So that we can have a little bit of reassurance before we go back and, call it a night and be able to sleep. So back to natural intelligence. And this is not really a trick question, but you talked about humanoids, right? And sometimes we are very busy people, and we can't be in more than one place at one time. But is it possible, Paul, maybe as a 2020 experimentation of sorts, for me to look into a humanoid intern to shadow me for 1 year and maybe, sort of not be my clone, but be my twin and get some things done?
Not in your lifetime and not in my lifetime.
Okay, that's reassuring.
It won't happen. It won't happen. There's just not enough compute power in today's microprocessors and accelerators to make that possible.
Okay, so when we talk about natural intelligence, we can train essentially AI through deep learning and machine learning to decipher the data, etc., and to do pattern recognition. What do you think is the difference between the type of pattern recognition they do versus what we do? I mean, you talked a little bit about judgment, so can you share about that?
Yeah, the biggest difference is, how do I explain it very simply and very quickly, is judgments that we can make as humans very, very quickly that computers are just not able to do unless they've been trained that way through the data that's gone into them. Like we're able to tell the difference typically between the paw of a cat and the paw of a dog, even a toenail on a cat paw versus a dog paw. But unless that level of granularity was put into the training model that tells the difference between cats and dogs, it's not going to know. The training models in machine learning are only as good as the granularity and scale of the data set that was pumped into it for it to learn. Mm-hmm. Now, humans have a concept of gut feel, and so far I have not seen any AI models or machine learning models that kind of have a gut feel neural network.
Yeah. So I'd like to add to that and possibly save you from troubled waters since I put you there in the first place.
Okay.
So I'm writing my second book called Breaking the Code of You, Find the Problem You Were Born to Solve. Now, a lot of times we look at personality profiling tools that you might be familiar as well, but it's only one piece of the puzzle because I don't think, a page result can possibly tell me who I am. So if we look at the concept of, a gut feel, the question is, why are we as human beings designed with certain powers or certain capabilities that robots up to this point do not possess? So I believe that each and every one of you in this room, including myself and Paul, was born and brought into this world to solve a very specific problem that you are uniquely equipped and designed for. So in this coaching mechanism that I talk about in my book, we look at your background, which interacts with your personality type, or what I call your core genius, as well as experiences to form your USP. Now, in marketing terms, we all know what that is, but I call that your unique superhuman power. And each and every one of you here is able to do something that, firstly, a robot can't, and secondly, someone else can't, right? Because, like you said, it goes back to who decides and who programs this algorithm to solve a particular problem. So I think the hope that we have moving forward as a human race and as individuals, as innovators, as managers and leaders in the marketplace, is that we have to be very clear on two things. Firstly, what problem do we want to solve? And secondly, how are we going to apply ourselves in the decision making of things so that we are the ones who decide, what the algorithm or these solutions and products are used for. So I think the fear that we are going to be displaced by robots is possibly not unfounded, but there's a lot of potential in the unexplored space of who we can be as creators, and you have on your very illustrious career journey been able to witness the rise and fall of different technologies. But time and again, it is man, it is mankind who's been able to rise from that. And with that, thank you very much, Paul, for your wonderful words of wisdom. Can you leave us with a final, takeaway that would be, memorable for not just us sitting here, but for our online audience as well?
Yep, absolutely. So where to get started? For our visitors in the room here tonight, there's a fantastic display of books over on the tables here on your left. And for all of our online streaming watchers, there's a couple of really good getting started reports. One from the Alan Turing Institute in the UK, very well-respected research institute. Alan Turing, interestingly, or whatever, was one of the very first people to coin the phrase artificial intelligence. When did he do that? Around 1955. 1955. So there's nothing new about the concept of artificial intelligence. And then secondly, the Singapore government's Model AI framework is actually a very easy read and has a very good healthcare use case as to how a healthcare provider is implementing ethical AI in their application here in Singapore. So two very good places here to get started.
Right. I like how you brought up the governance framework, because today earlier I was at the Asia House Global Trade Dialogue, and they said that Singapore is one of the smart cities, nations rather. And you can use data to do a lot of things like traffic control, air quality control. Yeah, so good on you for that. Yes. And all the best with your PR application. We hope the right people are watching online. So thank you very much once again, Paul, for sharing so generously with us your knowledge. And we're so blessed to have you. And thank you, ladies and gentlemen, for being such a wonderful crowd. Silent, albeit, but I can feel the good vibes coming our way.
And thank you to our online audience.
Yes, thank you so much. And we'd like to... Also, a big round of applause for the NLB team, headed by Evelyn and Yulin as well, for all the hard work that they've put in to make Geek Out possible. And of course, Indra and his sound team that has made it possible for the online viewers to be part of this experience. My name is Dazzling Chong, CTO of Great At You, and Purpose Coach. Remember, you were born to solve a problem. You were created to bring into this beautiful world. Have a wonderful year end. We'll see you again next year. Bye.